report. What am I expecting? Just the trend. And on this front page, type it, and you've got, first of all, the procedure, strange universe. That's supposed to look like procedure. Then you've got the quantitative analysis and the qualitative analysis. Okay, the qualitative needs to include uncertainty. And then what do you think, what other tool for error analysis, quantitative analysis do we need? Like, how many trials did you have? Yeah, there was only one per sphere, right? So do you need standard deviation? No, because when is standard deviation used? Yeah, you have multiple trials of the same exact procedure on the same material so that you can see how well you're executing your procedure. Okay. On this, because of time constraints, what we're doing here is you're going to pick a different thing to use. What should I use for this lab to be able to determine whether or not you did a good job? But what should you use? What's that? The other balls. I'm not sure. What do you mean the other spheres? Oh, okay. Let me just get to it so that we can go on. You're going to be using. Well, okay. You were supposed to find what? What was the point? Yeah, you were supposed to identify the materials that the other spheres are made out of. Yes? Yes. And you do this by calculating a specific heat. So do you see you are shooting for an actual value? Now, what error analysis tool would you use when you're shooting for an actual value? Yeah, something about error. Remember, there was deviation, and then there was error. Deviation, as in standard deviation, was how far you're off from an average. Error is how far you're off from an actual value. And which error should you use? Absolute would be like, guess how old I am? You say 60. I smack you. No, I'm just kidding. You say 60, and I say, no, you're off by 18 years. Okay? You're like, really? If you're off by 18 years, you could look at that error two ways. Absolute is what Sandy just mentioned. That would be 18 years. What's the other way? Relative, right? And that would be 30%. So which should you use for this lab? So if you use absolute, how do you tell whether or not you did a good job? Because, for example, let's say you're 10 joules per kilogram Celsius degree off. Is that a big amount? If you're talking about aluminum, no, because aluminum is 900. But if you're talking about, I don't know, naphthalene or benzene or something, these have really, really low specific heats. So then, yes, you would be off by 300 or 400%. So rather than absolute, which one should I use? Relative error. So you are going to use relative about percent. This thing is lagging. Relative error. So remember, your final equation for like WAL X, what is X? Whatever material the sphere is, what you're looking for. Okay, this is going to give you 4 different ones. So how do you write, how many things in here were measured? One, 2, 3, 4, 5, 6. And in each of these temperatures, that was 2. But just go with the delta T. That's fine. That'll give you actually more error than just the other. So if you use the delta T, right, then you have 6 things that you have to include in your uncertainty calculation. So my uncertainty calculation is what is this? Sigma 1 plus sigma 2 squared, sigma plus sigma plus squared plus squared. Those is an uncertainty. 3 for masses and 3 for delta T's. Does that make sense? No? Yes? Okay.
So it's just basically.
So it's like the uncertainty of the kind of the difference, right? Or the uncertainty part over the measurement, right? Each one, it's like the plus or minus, you know, that thing over the measurement. And then you're going to get that to get uncertainty, and then you get relative error, which is in a percent. Do you see why we chose relative error? Because now I can compare this to this. Because when you get a final uncertainty, right, this is going to give you a number, like a value that you can use as a percentage to compare against this. So if you come up with an uncertainty of, I don't know, let's say I have an uncertainty of like 10%, but your relative error is 8%, then, I mean, if you actually did everything correct, that's pretty amazing that you were off only by 8%. Either that or you picked the wrong ones. Yeah. So then these two numbers, right? These two numbers should be mentioned in here. We did a good job because of this. Also, the 4 sphere types, should be mentioned in there. We think the 4 sphere types are glass, molybdenum, granite, and gasoline. Whatever. And then you're going to say why you think, do you think your answers are good or not? So I would say, I think our answers are really bad because I don't know what molybdenum is, gasoline's a liquid, and whatever. Granite doesn't look like any of the metal balls that we played with. So yeah. So also, remember what we've said before, right? When you have multiple papers, older stuff goes on the back. Okay? This, like the back thing should probably be the lab sheet. I think that was the oldest thing you have. You probably took your data on that sort of stuff. If you did your calculations, please make sure highlight, right, yes, calcs and important values. Highlight calcs and important values. Yeah.
That equation in the top right hand corner, that's his.
Yeah. So any other questions about how this works? Very good.